Yeah, so hello everybody. My name is Oliver Grawert. I'm working at Canonical since 2005. Did the ARM port back then when we started supporting ARM. Have always worked in the smaller areas of embedded and well, the porting stuff. And doing this, you learn a lot about what's really bad in embedded and what's really hard in embedded. And over time, I had more colleagues that worked in similar areas. So we started considering probably changing what we offer there. And out came Ubuntu Core and Snap packages. So Ubuntu Core is built around the Snap package format. The Snap package format is actually a compressed and GPG-signed read-only Squashfs. The packaging info that you need for it is held in a YAML file that you just dump in your source tree of your project. And this YAML file actually knows everything about your project. You have to set it up once, but never touch again unless, well, probably some dependencies change or something like that, so you need to add or remove a dependency. But it's actually something you do once and never touch again, and then you can just go on doing your normal development. And if you want, you can just quickly create a new Snap package to test it out. Snap packages come in 4 types. So there is the normal app Snap, which is, well, an application, a server. If you use the Debian world or are used to the Debian or Ubuntu world, I'd probably describe it as like a meter package, where you join different things together, like if you want to have the lamp stack in one go, you might create a meter package that depends on the different sub-packages of the Debian format. And in a Snap, you can just join all these together in one package and even have it set up automatically. There is the OS and the gadget and the kernel Snap format, which is pretty much self-explanatory, I guess. Well, the gadget probably not, but I'll get to that a little later. And I'll actually do more introduction of the single snaps during the talk. A snap is designed in a way that you can always roll it back to the former version. So if you have your lamp stack, and there's a new MySQL in it, and that didn't really work out because there's something you wanted to try and it didn't really do what you wanted, you can just roll back to the former version and everything still works again. No breakage done, no damage done. Currently not available on Ubuntu Core, but on the desktop version. What we will soon enable it is the feature to use binary diffs. So the Snap packages come from a server. And since you have a local package and a server package, you can make a diff between the two to find out what has changed and, well, actually get only the changed binary data and have it applied locally. In a secure way. It is a bit difficult to do because the packages are GPG signed on the server as well as locally. So getting that right without breaking the signature wasn't an easy task, but it works now. Snaps are, well, as I said, available on the desktop and on multiple distros like Arch, Fedora, SUSE, and on Ubuntu indeed, and all the derivatives. So you can actually do development on your desktop, try the Snap out if it's not super hardware specific. try the snap out. If it works on your desktop, just rebuild it in the build system and have it deployed to your IoT board. Yeah, as I mentioned before, snap package security is achieved through, first of all, being a read-only squashfs, being GPG signed. But there's also other bits in the system that make sure that a snap can't be misused. And parts of these live in the kernel. So that means we need certain options in the kernel enabled. And we need a few patches, sadly, because the snapd tool that maintains all these security bits actually relies on the latest versions of AppArmor. But I'll get to that later. We actually offer the patches. There's a link in the slide where you can get the security white paper that explains everything very, very detailed. The snap applications are so constrained that we decided if we run a daemon, we want it to run as root. If your daemon could break out, then we have screwed up and the security doesn't work. So since it is clear that the security has to be so constrained that not even root could do damage, we default to having a root user. You don't really have to have a MySQL user or whatever because the guarding around it keeps you so far from the system that you can't really do anything, even though you have a root user inside the constrained environment. But indeed, you do want your application to interact with the OS. You do want your application to interact with the outside world somehow. So we poke little holes in the security model and call that interfaces. An interface always has two sides, one provider and one user. So a slot provides features like network access. And a plug in your application can then make use of the network access slot from the system. You have to define these in your big Snapcraft YAML file that you write once, and then from then on it will just work. There are some interfaces that are auto-connecting, and there are some interfaces that are not auto-connecting, where you have to manually do it. You can imagine it's similar to, I wouldn't call Android a good security model here, but where you, if you would use Snappy on a desktop and would integrate it with graphical tools, then it would pop up a dialog. This Snap wants to access the network. Do you want to allow that? So the user could decide if he wanted the Snap to actually allow that. And here, through the Snap interfaces command, you can actually have all the system interfaces that are already available in your system. You can have them listed, and that's just a little excerpt of the typical set of interfaces. So initially we started with the 1504 images. We actually started with a kind of classic image, Debian-based image that then had Snap support for Snap packages. And then the idea came up, why not do everything as Snap? Like, have your kernel as Snap, and have your root file system one big Snap, which is our core Snap. And since we can do that, and Snaps have the rollback functionality, we can even, well, tinker with the bootloader a little to actually have a check. Did your system boot properly or not? if that didn't happen, just reboot into the former version. So if your kernel panics after upgrade, you automatically go backwards to the former version of the kernel, and your system still stays online. You can't really kill it or break it, which I think is very important for a system running my heating in winter when I'm not at home. And there's a security upgrade for the kernel, which I don't maintain myself because somebody does it already. Then while I'm not at home, I don't want my heating to be killed, but I still want the security to not have my heating being hooked up to a botnet. So this mechanism will save me from any of this. And as I said, we have these 3 snaps: the kernel, the core, and the gadget snap. And I'll go through the different snap types a little. So the core snap is of type OS. I gave you the types in the beginning. There was the kernel, core, and OS. On the desktop install, we actually used the core snap as an execution environment. You could imagine it as a container. I don't like saying container. It's so overused nowadays. And it isn't really a container, I mean. But yeah, it makes sure that every snap has the same environment everywhere. Which means I can build it once for one architecture, and it will run everywhere. On all versions of other systems, simply because my libc is always the same. Because all the bits and pieces it sees are always the same. On the IoT images, on the Ubuntu Core images, we made this snap the root file system. It's a logical step. You don't really want to add extra stuff or fiddle with extra stuff if you have a nearly working root file system. Oh, and I missed to say that, but our root file system is about 60 megabyte big only. So it's very, very small. And well, all you want to do there is to run the snap daemon, and for services you want to be able to have systemd fire up the services, so you want to run systemd. We guarantee you a shell, so you can use shell scripts in your snap. And we guarantee you the same libc version everywhere all the time. The interfaces I showed before in the long list on the left are actually provided by the core snap. So it gives you access to certain parts of the system. That goes as far as, I don't know if you read the press much, but Matthew Grawert actually attacked the security model of snaps, because if you use a snap on a desktop and use the X11 interface, it indeed gets all the insecurities of the X11 protocol. So don't do that if you really care for saecurity. But it is something you can't really get around if you don't use Wayland or Mir, one of the safe display servers. Then you will inherit all the insecurities of the X protocol. So this comes through an interface, and you could disconnect that interface. I mean, your application wouldn't do any graphical stuff anymore, but it would then be as safe as any other snap. In the OS snap, we have also a configuration interface. So the snap command, which you use to snap install and snap remove and snap refresh, can also use set and get for certain snaps. So here I'm actually showing the info for the core snap. You can see that it comes in different version in different channels. That means my buddies in the company, in the QA team, can actually grab the candidate snap and run all their tests on it. And once they think it is stable, they can promote this version to stable. And while I develop stuff, I'm indeed using the Edge channel, and there I break all the time and play with things. And if you use the Ubuntu Snap Store, which you don't have to, by the way, you could run your own store, not with all the bells and whistles we offer in the Ubuntu Store. If you use the Ubuntu Store, you will always have these 4 channels, and you can always decide what you use for which. So as I said, there are some configuration options you can use. Not many yet, but they grow over time. Since Snap is, or Ubuntu Core is a completely rolling model, you constantly get updates and improvement. So this configuration interface will grow and grow and grow. I just have the hostname management ready. That will end within the next 2 weeks. You will be able to set the time server. You are able to turn off logging at the moment. So people ask me about, well, doesn't it wear out my SD card when I run syslog? So I gave them an opportunity to just turn off syslog. And similar to how you can disable the SSH service. I try to show here that you can either directly call the whole option, which then just gives you the value of the option, or if you use a higher level, so drop off the last part, you get a JSON file, which you could also feed into it. So you could write a little JSON file that actually configures your whole system with all the configuration options in them. So let's get to the kernel snap. As I said before, we need some newer bits in AppArmor. Currently, I think it's AppArmor 3.6 that we require. And we actually offer backport trees, so you can just, if you have one of the supported kernel versions there, you can just pull that into your kernel tree from kernelubuntu.com. They go upstream, but often we require newer features than you have in upstream or in other kernels, so it might make sense to just use our tree. Since the core snap is read-only, but your OS wants to write to var or wants to set up certain bits in the system writable, there's a setup in the initrd that actually does that. It takes the core snap and uses a writable part on the disk to actually bind mount the writable bits into the system so it can boot. We have a Snapcraft plugin for the kernel. So if you have a kernel tree and, well, have the AppArmor bits in this kernel tree, you can just call Snapcraft at the top level and it will do the right thing. It will compile your Z image or your whatever image, and it will put the initrd in there, and it will create a snap. You can use any BSP kernel. We don't really have bigger requirements than, well, use the AppArmor bits and use a certain set of default config options. The config options can be found under this URL, and where there is namespace support, is required, and seccomp needs to be enabled. And yeah, I mentioned before that you can always roll back your kernel, or it rolls back automatically when something bad happens. So this is probably the most interesting snap in the image, because it defines what your image is. It tells what kind of partitioning you need. If you look at I don't know how many times you looked at Dragonboards already, but you have 8 partitions in the top that don't do anything to your system. They are just there for booting. So the tool building the image needs to know that you need these 8 partitions, that certain bits need to live in there, and there are signatures in the GPD that these binary blobs look for to chain load each other. So that's what I described in the gadget YAML file to actually make these partitions available on SD cards. Since we don't boot from the MMC, we don't touch the MMC at all in the moment. Indeed, we need to ship the bootloader somewhere and the config for it, which, as I said before, has some specialities in it, like the rollback. And indeed, it can tell the system that it wants additional snaps, like as I described in the bottom. You might want to do a video player appliance and have Kodi as a snap in your image. You can define that in your gadget. And you can define that your system needs certain connections, certain extra interface connections to actually run whatever you pre-install there. This is, for example, it's not the complete one. I had to cut a bit out, else it wouldn't be readable. But this is, for example, the gadget YAML for the Dragonboard. We have very detailed documentation online. I'll point to it later. For each of these options that are listed there. But as you can see, I can define the bootloader here. It could be UBoot or grub. That's the only 2 we currently support. I heard upcoming boards won't necessarily support UBoot, so we will probably find a 3rd option. These are the partitions I talked about before, of which you have 8. I didn't show all 8. With the types that you need there. Here I define where the device tree lives and which device tree file I want to use. And at the end, you see, here's my UBoot image, and here's my VFAT partition where all additional stuff can live that I need for booting. We provide a tool that's called Ubuntu Image. To build an image, I need to provide a GPG-signed text file. I'll show that later. Ubuntu Image reads that gadget YAML file and then creates the partitions that were defined in there. And out comes either an SD card image, as we produce it today, or if we ever want to actually provide an eMMC image and don't really want to repartition the eMMC, we can predefine IMG files that you can DD into the different partitions. Ubuntu Image is available as a snap on your desktop if you run Ubuntu LTS, any LTS, 14.04 or 16.04. And you can find the documentation for it here to actually, well, try it out if you want to. This is the assertion file that I mentioned before. It has the GPG signature in here and tells you which key was used, which is, in this case, the canonical key. And it says which gadget and kernel snaps are in use. So in my Kodi example, I would actually have the Kodi in the Dragonboard gadget and would use this assertion file to actually create a canonical signed official Kodi image for the Dragonboard. As you can see, it says which architecture we use. I think it is possible to actually run ArmHF on the Dragonboard. I haven't tried it, but it should be possible. So in that case, I would put ArmHF in there. As I mentioned before, it's pretty easy to create a snap. You just have this single file in the very top level of your tree, and can then, well, just run snapcraft, and it will find the build dependencies, find the runtime dependencies. If you use something like Maven, it will use the Maven plugin to actually pull the right things in the right ways. If you use NPM, it will install the right NPM modules. So you don't need to do that yourself or need to care for it. It will just make available what you need. So it can actually integrate with anything that's out there already, or nearly everything. I'm pretty sure you would find some examples where it can't. Indeed, you don't need to build locally all the time. So there is full support for snap building in Launchpad, which means you can benefit off the different architecture builders that Launchpad offers. You could build your snap for S390X, or PowerPC 64, or ARM64, without having an ARM64 machine or a PowerPC machine. There is integration for GitHub as well. I think it uses kind of the snap of the Launchpad builders. Jamie knows more about that. I haven't used it yet, but you can actually directly build from GitHub into Snapcraft.io, and out comes the snap into the store. So you don't need to do anything. You can just have your commit, and there will be a snap in your Edge channel. And if you want to learn Snapcraft, it has a built-in tour. So you just run Snapcraft tour in your terminal, and it will guide you through. If you prefer to read about it, you go to Snapcraft.io, and there's all the documentation. So let's get into the very hairy details of the port for the Dragonboard. There you see the actual Snapcraft YAML file that you could use in this Xenial tree. We don't do that at the moment. I'm just repackaging the dep that we built before, because that's signed with the archive key in case we ever need secure boot in any way. Then this will use the canonical key. So currently, for the official Snapcraft, for the official Snapdragon, too many snaps. For the official Snapdragon kernel that we have in our archive, for the Dragonboard, we are not using this. But if you would rebuild your own kernel, you could actually just take this file or this tree and run Snapcraft in the top level, and it should come out as the same kernel without the secure boot signature. So if you don't want to use a Dragonboard kernel, we have a set of sample kernels on GitHub, and the full AppArmor 3 patch set that you need for full snapd support is can be found under that address. I haven't uploaded the slides to the Linaro system yet, but I will do that. So you can just look it up there. For using U-boot on the Dragonboard, or well, for using U-boot anywhere, we ran into a bunch of problems having the configuration as a text file on VFAT. And I've seen that on all embedded boards I ever used. If both sides, if the bootloader and the OS write to the VFAT, after a while it just corrupts itself. I don't know why. And to prevent that completely, we decided to drop that whole mechanism and simply use a binary blob of a U-boot configuration. So we now put a binary blob file into a VFAT that we then modify from either side. And since the size never changes and the position never changes on the VFAT, you don't get any corruption at all. It's atomic writing inside a binary blob. So it just changes bytes in there. But to achieve that, you need these two configuration options in your U-boot build. Which means we can't really, if that's not used upstream, which it usually never is, then you have to modify your U-boot build. And we don't really want to use any uinitRD fiddling or anything else. We just want to use the typical, as we use it in Ubuntu on the desktop as well, the typical initRD in a normal compressed format. So we require this initRD setting. This is all the magic that is being used to make sure that your panicking kernel rolls back. As you can see, there's a lot of if, then, else going on. And snapd actually sets a flag. Well, when installing a new kernel, snapd sets a flag in the environment. Then it tries out this kernel, and if this flag isn't gotten, then it will roll back to the former kernel. And we boot in a way that a panic always causes a reboot. So you automatically go back. And that works with the kernel, snapd kernel, as well as with the root file system. So if anything of your boot process would be broken because of a broken root file system, which you can blame me for, I would have broken it, then it would roll back. Since not everybody wants to use snaps all the time, and you might want to do development on your board, we give you an environment where you can actually just use a standard Ubuntu environment with apt and dpkg and everything. You can just install the classic snap in dev mode from the Edge channel and run sudo classic, and you end up in a sudo shell or in a root shell in a classic system that is using exactly the same squashfs that you booted from. So you can be sure it's 100% identical. And it bind mounts your home file system, your home directory, so all the work you do in there is available to the normal Ubuntu Core system after you left with exit from the shell. That means you can install Snapcraft in your board and then build with Snapcraft while developing or tinkering. So if you feel like contacting us and didn't fall asleep yet, I know it's hard, it's late, and I'm not a super exciting speaker. If you feel like contacting us or have questions, here is a set of URLs and mailing lists and, well, channels. That's it. Oh, I should probably, in case somebody wants to write something down, leave that here. So if there are any questions, I'm here. Thank you.